What's becoming really clear is that the way we are consuming energy, we're moving energy, we're producing energy, is not sustainable. Sustainability means meeting the needs of the present without compromising the ability of future generations to meet their own needs.
This is The Energy Canvas, bringing energy solutions to life, with your host, Celtic Dynamics CEO, Dylan Walsh.
Hey, Dylan here. In a world of rising energy costs, global uncertainty, and urgent climate targets, how do we keep the push for decarbonisation moving forward? One answer may lie in the innovation and in the engineers driving it. Today, we explore how engineers can lead real climate action, what hydrogen means for Ireland's future, and how research is turning ambition into impact. To chat about this, I'm joined by Head of Mechanical Engineering at the University of Galway and coordinator of Shamrock, a 54 million project creating Ireland's first hydrogen valley. Professor Rory Monaghan, you're very welcome.
Thanks, Dylan. So I'm Rory Monaghan. I'm from Galway. I work at the University of Galway, where I lead a research team that works on decarbonising energy systems. We work on a number of technologies that I'm happy to talk about. I also teach. I teach in our mechanical engineering and energy systems engineering courses here. So I get to have a hand in, shaping the people that are going to have a real impact on energy decarbonisation in the future.
Cool. Okay. So I suppose to start, Rory, what do you see the role engineers have combating this climate change and how it's changing as we move towards the net zero targets?
Yeah, it's a really interesting one. Like, to me, in my daily work, it almost seems like a bit of a no-brainer that engineers are going to be at the forefront of climate action. But I sort of feel it's important to talk about this because when I go into schools, when I start talking with undergraduate students here, they can't see it. They sort of almost think that engineers have set up the world as it is now and are trying to keep it the way it is now. The reality couldn't be further from that. Engineers, basically, our job is to develop products, processes, new technologies for society's use. And what's becoming really clear is that the way we are consuming energy, we're moving energy, we're producing energy, is not sustainable. Sustainability means meeting the needs of the present without compromising the ability of future generations to meet their own needs. And the way we're consuming, the way we are living our lives right now as a whole is not sustainable. We're robbing from the future. Where engineers fit into this is we need new technologies that will use energy more effectively, more efficiently, that will do the things we currently do better and will enable us to do things that we haven't yet imagined. And on the flip side of that, we need the energy to run these things. We need the electricity, we need the hydrogen, we need the different sorts of fuels that are going to be necessary to power these technologies of the future. So engineers have got a role to play there too.
Okay. I suppose then you're in lecturing and everything. How is education evolving to prepare these students for these new, they've got to come up with a bunch of new ideas to get this energy ready. And then they've other new ideas on top of that are going to run off the energy. How's preparing them for that, or the change and preparing them for that going?
I think it's evolving all the time. I think, the presence of new technologies keeps changing that. I guess there's a few, there's the traditional engineering skills that will always be the same. The ability to solve problems, the ability to deal with, complex situations and come out with some solution that makes sense. I think, since the beginning of engineering education, we've been striving to do that, and we're going to keep trying to do that. But I guess there's a couple of new aspects of engineering education that we are really trying to improve. One of those is to not just have engineers thinking about how our solutions impact on the environment, in terms of almost like an afterthought that, we design something, we have something built, what's its impact on the environment? We need to be able to have from the outset a better understanding of, can we design something, can we build something in a better way for the environment, that it's not just about understanding its potentially negative impact. It's about designing it from the outset so that its impact is positive rather than negative. So that's a kind of an established area in terms of engineering ethics and nature-inspired design that we're trying to, get our engineers up to speed with. But I guess maybe a more fundamental thing that we always need to be conscious of with engineers is that we're actually addressing problems that society has, right? I think there's that phrase that when all you got is a hammer, everything looks like a nail. And I think sometimes with engineers, we equip engineers with all of these complex problem solving tools. And the stereotype is that engineers will give you a really complicated solution that is just complicated for the sake of it. Whereas I think what we really need to be thinking is, how do we educate engineers in understanding what exactly society's needs are? And I think, getting our engineers, our students, more face time with the community, with community groups, with stakeholders in industry, with policymakers, helping them understand what are the real challenges that society and the people face. And we sort of use that as the jumping off point for the engineering technologies that we know they're going to be able to develop.
Mm. Mm. Okay. Well, I suppose then, in terms of engineering research, you're probably involved in a lot of different things then, is there any ones that are particularly interesting in terms of shaping that policy or business practice for going forward?
At the minute, my research team is very active in hydrogen research. Hydrogen is a sort of a technology that has come and gone in waves. Every time it gets attention again, it's massively hyped up and the hype bubble bursts, and then we're left with trying to see what we can really do with hydrogen. So it was the technology which more than 20 years ago was what sort of inspired me to get into research. When I was an undergraduate student, I did a class report on hydrogen technology, and I had never heard of it before. And once I did that, I really got, inspired about, wow, this is something that's really interesting. So that sort of got me thinking about research. I went to the United States to do my master's and my PhD, and that was on hydrogen technologies. I guess by the time I arrived back in Ireland after that, the previous hype bubble about hydrogen had died down, and it was difficult to make much of an impact in doing work in that area. But the last maybe 8 years or so have seen a real uptick in interest in hydrogen. So this is my long-winded way of saying that we do a lot of work on hydrogen. We do hydrogen studies on sort of two fronts. One is we build mathematical models of how hydrogen might fit in an economy, where it might be needed. We take that starting point of, rather than go around and saying, here's hydrogen, use it, we're sort of saying what sectors might need it. If every sector needs to decarbonize over the next couple of decades, what's the most likely path for decarbonisation that these technologies are going to take? And most of them are going to be taken care of by improvements in efficiency or electrification. Those are, the two lowest hanging fruits in terms of decarbonisation for most parts of the economy. But then we sort of get to this bit that's really, really hard to decarbonize. It might be that we're looking at how to fuel aircraft or fuel ships or fuel really long distance trucks, or very high temperature processes in industry, or energy storage for extreme periods of time, months, weeks or months at a time. So there's potential roles for hydrogen there. So once we establish what potential roles are, we build mathematical models to decide what's the most cost-effective and environmentally friendly way to produce that hydrogen, to store it, to get it from where it's made to where it's needed. And we call this hydrogen supply chain modeling. So that's one aspect of what my team does, and that's purely computational based, and we work with industry to sort of validate what we do and to build their assumptions into our models. But then the other side of what we do is completely different, and we coordinate this project called Shamrock, which is a plan to actually put hydrogen infrastructure in the ground in Ireland. This would be the first of its kind in Ireland. There's a few projects like this across Europe. This is a project called a Hydrogen Valley. And it's something that that I'm tremendously excited about, that we could be seeing real life installation of these technologies and a demonstration of what they could do in the Irish energy system.
I suppose there's two fronts then from that where, everyone else is going to have questions. Let's assume they're not an engineer first, okay? How do you get hydrogen in the first place is probably a good question for everybody. Yeah.
Absolutely. So So yeah, hydrogen it's a molecule, it's a gas, it's filled with contradictions. It's the most plentiful element in the universe. More than 90% of the mass of matter in the universe is hydrogen, but it is mostly contained within stars, right? And it's going to be very difficult to go up to the sun and start mining hydrogen out of the sun. So hydrogen only really exists in significant quantities when it's locked in with something else. And those two something else's that it's generally found with on Earth are water, which is H2O. The H is for hydrogen. So two hydrogen atoms and one oxygen. And hydrocarbons or fossil fuels. And fossil fuels are complex combinations of carbon and hydrogen. So we need to, if we want to extract hydrogen from something, we need to put something in to get it. We need to either mine fossil fuels and process them to crack the hydrogen out of them, which, you know, if you're interested in renewable energy and decarbonisation like I am, there's not much point in doing that. On a pragmatic level, Ireland doesn't have fossil fuels, or certainly not much of them. And burning fossil fuels and releasing the carbon dioxide is what's caused us to be in this climate crisis in the first place. So let's look then at the making of hydrogen from water. Well, why would you do that? The way of getting hydrogen out of water is a process called electrolysis. And you essentially need two ingredients. You need water, where the hydrogen comes from, and you need electricity that splits the hydrogen and the oxygen apart. And if that electricity comes from a renewable source, you can think of this hydrogen as almost like a battery that stores the energy of the renewable electricity. So, you know, imagine a future Ireland where we predominantly use onshore wind, offshore wind, and solar to produce our electrical needs. And let's say that in order to produce our enough electricity over the course of the year, we need to generate far more in the winter when it's windy, where we have the wind resources, than we do in the summer, where there's far less wind. So how do we store that extra wind from winter to summer? We could charge up batteries, but batteries are very, very expensive to store energy over very long periods of time. Extremely expensive. Batteries are excellent, but they're generally suitable only for short periods of time. We could do some sort of old-fashioned techniques like taking that extra winter energy and pumping water up hills to store in lakes at the tops of mountains. We do that. People all over the world have done that for about 100 years. It's a very established technology, but it does require a lot of sort of massive civil engineering projects, massive changes to local environments, and it can be sort of prohibitive from a biodiversity point of view to do that. And then, so the approach that we're looking at then is using this extra energy in winter, if we use wind. If it was a sunny country, we might produce extra solar power in the summertime. Use that extra electricity to split water, store that hydrogen in a big tank, or store it in an old gas field, for an old fossil fuel gas field, for example. And then we use that hydrogen as a source of energy when we don't have enough wind to run our electricity system. You know, I like to think of it as a very, very long-term battery.
Mm-hmm, mm-hmm, mm-hmm. And then I suppose in terms of shamrock, then one, you've got a place where you're going to store it, you know, and where's that coming from? And two, I suppose, what's the end goal for shamrock in particular in terms of use?
I'll explain the pieces of shamrock, what it's all about.
Mm-hmm.
So shamrock sort of came from initial conversations that we had around Galway maybe 7 or 8 years ago, where I got talking to the operator of a wind farm, and they were telling me that, look, it's great, we've got this wind farm now, it's producing clean electricity onto the grid, but there's sometimes that the grid doesn't need our power. And when the grid doesn't need our power, there's no, you know, it could be, say, at nighttime when there's low electrical demand, but the wind is still blowing, we can't switch the wind off. The grid does not need that electricity. And because we don't have a means to store that electricity, the grid operator, EirGrid, would instruct the wind farm, stop your turbines from turning. So actually put a brake on your turbine, let the wind pass over them, but don't let the blades spin. And that is such a wasted opportunity. You can nearly see Euro signs fly past the wind turbine that's not being allowed to spin. The wind farm was interested in ways that how could they stop this extra electricity going to waste? When they went to all the trouble of building the wind farm, all the expense, all the interaction with the local community, and yet they're not able to sell all of their electricity. So we started talking about battery technology with them. We started talking about hydrogen, and they were very interested in hydrogen. But what we found with the conversation with hydrogen was it all started to break down for the point that you raised there, Dylan, which is, where would we use it? It's once you have hydrogen, there's no point in having it unless someone wants to use it. So the wind farmers, they weren't interested in building a hydrogen fueled engine that they could use to generate more power when their wind farm was down. They're wind farmers. They're not, engine operators. So we had some other conversations with the national bus company, Bus Éireann, and they have got big plans for decarbonising all of their buses and their intercity coaches. We had some conversations with local industry here in Galway. There's a company called Colas they're responsible for the construction and upkeep of most of the major roads in Ireland. And so they use a lot of energy to produce the construction materials, the
tarmac and stuff.
Exactly. The tarmac materials. So really high temperature stuff, really high energy use stuff. They burn fossil fuels to produce that heat. They were very interested in being a user of hydrogen. And then we spoke with Galway Port, because the port is it's the center of Galway City. There is depots for buses, for coaches, for truck fleets. The Colas import the bitumen, which is the raw material they use for making roads, into Galway Port. So Galway Port became this sort of obvious hub for where we could do some work on decarbonising the really most difficult pieces of the energy system. So once we had the port, the wind farm, and the transport companies involved, we sort of realized that we had a project. So we went to the European Union. We put an application together, and they funded us. We're very grateful for that. So they funded us to the tune of €8 million to get our project off the ground. The total amount of investment that's needed in Shamrock is going to be much more than 8 million, but the 8 million is a great start. And this is going to allow us to produce hydrogen at a wind farm in County Offaly, and it will be primarily using excess unneeded wind electricity. It'll be compressed into high-pressure tanks and trucked to Galway. We're building a fueling station in Galway, a hydrogen fueling station in Galway, and we're aiming to use that hydrogen to decarbonise coaches that drive between Galway and other cities, trucks, some buses, and this industrial process involving the road-making materials. And we're even talking with the small airline to do a flight trial for a hydrogen-powered aircraft as well, which can get small. It would not be the Ryanair type airplanes. It'll be a smaller plane, the plane used to bring people to the Aran Islands and back from Connemara. So we're trying to demonstrate and prove the use of hydrogen in lots and lots of different sectors.
I suppose the question that comes to mind from a business owner's perspective would be the security of the resource then. I suppose it's more of a pilot. Have you thought about future security, or do you think the wind will have enough excess, or what's the current?
I guess this is something that it's not a technical objective of Shamrock, but it is very much something that we want as an outcome of the project. Is we want this to be a spur for other hydrogen projects to come on as well, because you sort of hit the nail on the head there that there's a big fear with any new technology when you come to rely on a new technology or a new fuel like hydrogen, that if your supply goes off for a time, what do? You've invested all of this money on hydrogen fueled vehicles, and if your sole supplier of hydrogen is gone, what are you going to do? So we're looking at a few things. First of all, there is a small amount of industrial production of hydrogen in Ireland. That company that produces that is a part of our project. So if our renewable hydrogen production goes down, we can step in with some other production of hydrogen as a bit of a stopgap. But what we really want is to encourage other projects like us to get off the ground, because the more producers there are, that gives more security of supply to users. The more users there are, that gives more security of offtake to the producers. So everyone benefits when there's more projects up and running. And, we're aware of projects that are trying to get off the ground in Cork, really big project in Cork. There are plans for hydrogen fueling stations in Dublin and Belfast. There's plans up in County Cavan for hydrogen at a major industrial facility. So there's lots of projects that I think are, it's not like they're waiting, but they are trying to see how our project goes, how it gets supported, and then their projects will hopefully start to become a bit more viable once there's a project up and running. And that's why this European funding that we've received is so important, that it's kind of giving us a bit of a seal of approval that this is supported at a European level.
Yeah, I've heard of quite a few other projects from people, but I suppose everybody's approaching it from slightly different perspectives. Yours is mainly going to be compressed gas and then resold. So
I guess what I would say is that if we were looking to do a full, grid scale hydrogen project, we probably wouldn't do it the way we're doing it now, right? We wouldn't produce it at a wind farm in Offaly and then load it into trucks to bring it here. We'd probably try and do something more like, we'd look at pipelines for moving the hydrogen around, much more cost effective when you're moving hydrogen in bulk. We would probably look at, purpose-built wind farms, maybe even purpose-built offshore wind farms, because the wind is very consistent. We could produce the hydrogen. You could even produce it offshore. We could look at exporting the hydrogen. But this is like mega scale. This is huge scale, and we need to demonstrate something at small scale first. We need to let the key stakeholders in Ireland, like the policymakers, the players in the energy sector, we need to have them get experience with hydrogen at some scale. And I guess going to the big idealized scale using geological storage of hydrogen, it's too much of a risk to take for that first step. So we need to, to get the gigawatts, we need the megawatts first.
Yeah. Okay. And I suppose you brought up the issue of vehicles, is there a lot required to convert some of these vehicles, the plane, the boats, the buses?
So what we're finding a few challenges here. So the first challenge, and it probably comes into every energy sector conversation, the first challenge is Brexit. That we had a really, before Brexit, we had right beside us a really large internal EU market for vehicles that drive on the left-hand side of the road. Okay. Why does that matter? Well, hydrogen vehicles, they're sort of rare at the minute. There's not a huge amount of them around. Electric vehicles, they've become a mainstream technology. Not so with hydrogen. So when we're trying to get hydrogen vehicles that drive on our side of the road, the UK or Japan currently are the only, places we can really go to at the minute. It's very unlikely that a German or a Dutch or a Spanish manufacturer of vehicles is going to make a couple for Ireland when our market is so small compared to everyone else's. So we found that we are, getting brand new off the production line hydrogen fueled vehicles is quite challenging. So that brings us to the conversion conversation. So there's two ways that you can do a conversion to a hydrogen fueled vehicle. If your starting point is a diesel fueled vehicle, there's a relatively straightforward conversion where you take out the diesel tank, take out the fuel supply manifold, and replace it with hydrogen. And you've got now a hydrogen burning vehicle. So this is combustion of hydrogen in a very, very similar setup to how, if people might be familiar with CNG vehicles, compressed natural gas vehicles, or any gas fueled vehicle. Hydrogen, we need slightly more high spec materials because the molecule is so tiny, it will leak out through any crack or any gap in a seal. The hydrogen will leak. So the materials need to be quite highly spec'd, but we know we can run hydrogen burning engines. So for things like heavy duty trucks, we can we can convert heavy duty trucks from diesel to hydrogen. For ships, diesel burning ships, most ships run on, or ships of fairly, average size, run on diesel burning piston cylinder engines. And so we can convert those to hydrogen too. And a lot of the makers of those big heavy duty engines are working or have launched limited runs of hydrogen burning engines. So the diesel to hydrogen burning conversion route is there. Then there's another conversion route, which is if your starting point is an electric vehicle. An electric vehicle basically uses a big battery pack to run an electric motor to turn the wheels of a vehicle. So, and for cars, this works great. My family has an electric car and we absolutely love it. We would never go back now. And for vans and light trucks, this all works out. But when you start to get to the heavier trucks, the trucks, big articulated lorries that you see in the streets or on the motorways, the ranges that they drive and the amount of cargo that they need to carry starts to put a limitation on the battery size. So the range of those vehicles can be restricted. So when your starting point is an electric vehicle like that, you can remove some or all of the battery pack and replace it with hydrogen storage tanks and a device called a fuel cell, a hydrogen fuel cell. And you leave the electric motor in place and the electric motor turns the wheels of the car. So what's happening now is rather than a battery powering the motor to power the wheels, we have hydrogen fuel being supplied to this device called a fuel cell that converts hydrogen and oxygen into electricity. It's kind of the reverse of the production process I talked about earlier. And that electricity runs the motor and turns the wheels. That's an electric to hydrogen conversion route. It's a little more expensive, but it can benefit from the rollout that's already happening of electric vehicles, some of which might be quite range limited.
So I suppose then, in terms of Shamrock, it's really, you're probably looking for a lot of people to get involved to help you then. Is that where the point you're at now? Like you're kind of started off and looking for more people to help?
Yeah. I guess, like I suppose we have a good partnership within the project, and we've got the core of the companies that we believe are going to be users of hydrogen in Galway in the near term. We are very interested in building a group of potential users that would be outside the project, but that could see hydrogen as being part of their business model. So companies like haulage companies would be
large CHP users, stuff like that.
Yeah. Exactly. So a big area that's very topical right now is data centers. Data centers, they are, as a sector, are becoming larger and larger consumers of energy in Ireland. They are tremendously important to the Irish economy, but the energy demand, the demand that they're placing on the grid, especially at peak times of energy consumption, is starting to become a little bit of a problem. And we're seeing that data centers are no longer getting permission to connect to the grid in Dublin. That's basically because at peak times, the electrical infrastructure in Dublin is finding it difficult to keep up with demand. So what data centers could do in that case is, when electricity demand is high, they could switch to their own supply of electricity. Now, for most data centers, that means burning gas, fossil fuel gas, or diesel, or some type of oil to do that, which is obviously not great when it saves the grid, but it's bad from an environmental point of view. So we'd love to, have conversations with data center operators to see, could we provide them with hydrogen fuel that is being produced when there's excess power, and they can use that when the grid is under strain. And it would be a few hours at a time of demand. It wouldn't be, vast reservoirs of hydrogen, but there could be a nice kind of synergy there between our ability to produce hydrogen and a sector that is extremely important for Ireland, that's being held up by a lack of power at certain times of the day.
Yeah. And I suppose at the moment, hydrogen is very new in the grand scheme of solutions in Ireland. I suppose looking at the grants and the policy guys, they're all thinking about, what are we going to do when this kicks off? What would you say you need as support? Is it grants? Is it funding towards fuel purchase? Is it funding towards some other kind of scale? What would make a good impact in the hydrogen market? Or is it funding the vehicle conversions or something like that?
So we have what's called a national hydrogen strategy in Ireland. And it's an excellent document. Most European countries now have released hydrogen strategies. Ireland was one of the last ones. And, I was a bit maybe critical of that at the time. But when our strategy was released, you could see that they had very definitely learned from other countries that had made mistakes on earlier versions of hydrogen strategy. So it's a really, really well considered strategy. And there has been a number of recommendations and, action points coming from that strategy. The issue that I've had with it, though, is that it has been so slow to be enacted. It seems that in Ireland, we make great plans, great strategies, really good policies, like climate action policy. It's a great, really detailed policy, but the inaction of it is really, really difficult and has been very slow. And so I guess if I had a lamp with a genie in it, what I'd ask for is just that the strategy be enacted, that, it's there, it's in black and white, and it is getting done, but it's slipping. The timelines are slipping all the time. I would love it to be enacted on time. Like, for example, I think it's action number 2. So it's really high priority action in this strategy is to create and disperse a fund for supporting pilot scale hydrogen projects. And, to my mind, what we're doing with Shamrock is, tailor-made for this. We're using excess wind energy. We're decarbonising the hardest to tackle sectors. We're not using hydrogen in sectors that make no sense. Like, we're not proposing hydrogen to go into people's cars. We're not proposing hydrogen to go into people's gas networks, into their homes to make cups of tea. We recognize that hydrogen is expensive and difficult, and therefore should only be used in the sectors where it absolutely must be used in. So that's why we're sticking to those. I would love if this hydrogen strategy could be enacted on time. I would love if the financial support that the department realizes is important, I would love if it could be dispersed on time. They are working on dispersing it, but just the timelines are so slow. We're worried that, we're a first mover project, the Shamrock project. We're worried that just the delays in the rollout of the funding are going to mean that the first project won't get to benefit from them because our timelines are earlier than what the slipped timelines are now working towards. So I'd love to see just a sense of urgency to enact what has been agreed to already.
Anybody's listening from these policies, speed it up, guys. Okay, so I suppose there's another aspect to maybe energy at the moment that, we kind of leave by the wayside a little bit in trying to move things forward. But I suppose at the moment, climate action, is it still possible and practical in the light of all the global uncertainty, conflict, changes and stuff like that? Is there anything you'd say on that front?
It's so hard to keep sort of the decarbonisation thing in focus right now when there's so many other things going on. And, the president of the US is putting out different conflicting messages nearly every day, and it's difficult to keep up. I think that the move towards renewable, sustainable, zero carbon energy, it doesn't just have a decarbonisation benefit, especially for a country like Ireland. It has got an energy security benefit, a physical security benefit, a good European citizen benefit. It's got benefits. It will, in the long term, have benefits in terms of cost. So I think we absolutely must keep working with this. Maybe the message becomes less about climate action and becomes more about national security, but it's the same goal. We're trying to do the same things in order to achieve these multiple goals of decarbonisation, of energy security, of cost. Like, we in Ireland, we've got the most expensive, first or second most expensive electricity in Europe right now. And that is, people in the street will tell you, oh, that's because of renewables. That's because of wind energy. It's not. It couldn't be further from the truth. It's the opposite. It's because of fossil fuels. It's because we rely, when the wind is blowing, we rely on wind predominantly for our electricity. And the cost of generating electricity from wind is very, very small, really small. But if there's a shortfall in what wind can provide compared to what the country needs, that gap is made up by fossil fuels. And because of the nature of how those fossil fuel plants run, they kind of only run when they're absolutely needed. The electricity from those fossil fuel plants is really, really high electricity. And the way our market is structured is that anyone selling electricity at the same time as these expensive guys gets paid the same amount, even if it costs them nearly nothing to generate it. So it's the cost of this fossil fuel backup on our electricity system is what's making our electricity so expensive. So if we can move away as much as possible from those fossil fuel backups, use things like batteries, right? Use things like longer term storage technologies like hydrogen and this idea of pumping water up and down hills. If we can achieve that, we'll be able to actually reduce our costs. But the narrative coming from a lot of people who want to keep the energy system the way it is the opposite. They're saying renewables, solar, wind is what's making our electricity so expensive, when it is the exact opposite of that that's happening.
Maybe just to wrap up, I'm going to ask you, what is one question you'd love to know the answer to from industry? Just in case any of them is listening. And I'll also ask our next guest, like if you could get any answer, what would be the answer you would like to know?
How can we ensure that the decisions that you're making on decarbonisation now are going to stand the test of time? I've got a good friend who works in the transport sector. They are making decisions on how to decarbonise their fleet. And one decision involves the use of biofuels. With certain types of biofuels from certain suppliers, there is some doubt over the provenance of these fuels, whether they are sustainably sourced biofuels, whether they're even biofuels at all. The decisions to do this, to invest in these fuels, are being driven by short-term sort of KPIs. You know, we need to get down to our KPI list and we need to meet our targets by the end of the year. But I just wonder, what kind of due diligence is there going on behind decisions like that? You know, and I know people are working to short timescales and they're making decisions with incomplete information, but I would just worry that we're locking in some decisions that we're going to come to regret. So I guess it's, how can we future-proof the decisions that we're making now and limit the amount of regrets we're going to have in future?
And I've one for you just because you're the first one, so I came up with a question for you. So if we were to focus on one thing between now and 2030, what do you see as the key area to get right in terms of climate change?
Key area to get right? Well, it's got to be unlock the planning system. You know, okay, so this is not an engineer. I'm not going to talk about an engineering technology here, but we have got so many wind farms, so many grid extensions, so many, key pieces of energy infrastructure that either are gummed up in our planning process or will be, that we just can't afford to have a planning process that goes on with endless reviews, that sort of leaves the door open to very, very small numbers of stakeholders who don't really have any legitimate reason for stopping a project. I think we need to just have a strategic focus when it comes to planning and say, the country needs this infrastructure. We just need to get building it.
Mm-hmm, mm-hmm. Yeah, I suppose, that's echoed by every part of industry. Projects take a while to kick off and planning slows things down, and then on top of that, funding and stuff is also added to that mix, So, yeah. Thanks for joining us today, Rory.
You're very welcome, Dylan. I really enjoyed that.
If you would like to find out more about what we covered in this episode, you'll find notes, links, and more in the description area of this podcast. Do remember to press follow for our show so you get the next episode automatically. Also, please do share with a friend who you think would find it interesting. Just tell them to search for The Energy Canvas with Celtic Dynamics on their podcast app. Our podcast today was produced by dustpod.io and brought to you by CelticDynamics.com. Until next time, thank you for listening.